one time from the beginning, all the pipes in the oil and gas industry, drill pipes, casing pipes, tubing pipes, they are connected by the thread. And all the threads are conical. You can see it here and you can see it there. It's even better to see it here. So they are different. The thread on the tubing pipe and the thread on the drilling pipe, they're different. But nevertheless, they are conical. Why? The conical threads have some good parameters, how to say? They are, okay, no, you understood me.
Yes,
so
sir.
they are better in few points. The first point is that if we speak about the metric thread, for example, here we have the metric thread. Oh, here we don't have. That's my favorite pen. Something strange. I feel it in the here. Okay. So, if we speak about the cylindrical metric thread here, metrical thread. So you can calculate how many lines here. Those many times I have to rotate to close it.
Okay.
Yes, is it clear?
Yes.
So, in the conical, if we speak about the conical threads, you see at the beginning, if we take this one is smaller and easier. If we put one cone to another, be careful because it's heavy. This one is from this pipe. If we take this cone for this pipe, at the beginning it has already done the half of its way. We don't need it to rotate as many times as many lines we have. It's one. The second is that this type of thread is much more better for hermetization. Metrical thread is never can be hermetized. It needs additional sealants, rubber sealants or some synthetic sealants. These threads, because of these parts of the thread and after the thread, the connection is almost hermetical. The next one, under the condition of the drill rig, here everything is simple and almost clean. But on the drill rig, you should imagine one time more, everything is vibrating. We see the top of the drill pipe, but the drill mud is containing, or here everything is dirty in drill mud, everything is movement. I think you guys, time to time you had such a problem. As for me, I like to make many things by my own hands. In my car, in my bicycle, it's kind for me of relaxing. So my brain is relaxing. I do something with my hands. And sometimes, if you have to put some knot, and this knot is not comfortable on the table, somewhere here under your car, you're rotating, and you cannot catch this moment. Yes, and imagine we are in the drill rig, everything vibrating, noisy, a lot of mud here, and under this condition, it's very hard to find this place to catch it.
Yes.
And if we have the conical thread, it's much more easy.
Yes.
It finds itself.
Yes.
And it finds itself, and it has already done the half of the way. And one more, perhaps the last, I know. If we speak about the metrical thread, the first lines and the last lines will be under the most severe conditions. They will break the first one. So the forces on it are not, I forgot English word, are not the same. Are not the same on all the lines. Oh, equal, yes. They are not equal. In these conical threads, the forces are almost equal. Not only the first and the last lines work under hard conditions. All of them are almost the same forces, and it's good for the prolongation and the rising the reliability of the connection. So, one more important information. different of them. I'll put it. They're the same or they're different? This one is from here, no? Yes, it's from here.
So do you need any help?
No, thank you. I'll say to you. So you see, if I put one cone to another, so before rotation, it has already did 2 or 3 parts of its way. You see that these threads are different.
Yes.
You see, this one thread, the smaller thread, is on. So this is, I forgot to say, this is the tool joint. The tool joint is a connector for the drill pipes. When we spoke about the casing pipes, we spoke about the couplings. What is the coupling? The coupling is, it has the inner thread from both ends. Both ends, like this one.
Yes.
So, like this one, it has the threads from the both ends. And this, and this, there are the tool joints. I have the theoretical information here. I'll give it to you. Okay. So, this thread, you see, it's easy to see without the tools. That this thread is rather small. It's much more smaller than this one.
Yes, sir.
So this thread is connected to the drill pipe. To the drill pipe. And this one, it goes to the tool joint of other pipe. So every drill pipe, at one, so this is the drill pipe, at one end of the drill pipe. So we have the tool joints on the both ends of the drill pipe. But from one end we have like this one, so-called father end. And from other end we have this so-called mother's end. You see? So this is from one side, this is from another side. Sometimes tool joints can be welded. Do you know what is welding?
Yes.
So they can be welded to the pipe. But most of all, they are screwed to the pipe. So you see, this is the thread for the drill pipe, and this is the thread for connection for this end. Is it clear?
Yes.
So why we so this is the drawing. Somebody did it. Be careful. Why we have to use the tool joints? Why we cannot to screw one pipe to another without these additional tools? The reason is very easy. So we have one pipe. With a thread. If we don't use the tool, just imagine one time more. If we don't use the tool joint, one pipe and another pipe. Is the picture clear to you?
Yes.
One pipe screwed to another pipe without tool joints. What is the main problem here in this connection?
If it will broke, make a big disaster, or how can I say, more loosen.
If so, this pipe, it works under very severe condition, and here in these places, the wall of the pipe is very thin, so it will be broken. That's why we have to use these additional tool joints
To protect.
for the connection. Sometimes, in
Got it.
sometimes there are used the pipes, drill pipes. Almost all of drill pipes, they are with the tool joints. But for example, the tubing pipes, they are not with the tool joints. They are with the upsets. So the pipe is the following: the pipe, and it has the it can have the outside upset. Moment. The outside upset to make this part stronger. Or sometimes it can be the inside upset. This way. Both of them can be. But the pipes with the upsets, they sometimes used for the drilling pipes, but as usual, drill pipes are with the two joints. I've told to you that some of the two joints, very often, they can be welded to the pipe. Do you know the technology? How they are welded? How?
Like big score. Big score.
Big score, what is score?
This you can use it to rotate something, but a big one to rotate it.
Yes, and what?
They join it and they rotate it.
Okay,
The
what
pipe.
what kinds of welding do you know? Do you know what is welding?
Yes, joint like
Yes.
electrical welding.
Yes. Something like here, yes?
Yes.
What kind of welding do you know?
Electrical.
Electrical or arc electrical, and what? Gas welding, and remember, very good technology for the welding of the two joint is the welding by friction. Yes, you can even find the movies on YouTube or something like that. The idea is very easy. The pipe is rotating very quickly, and we rotate it very quickly in special equipment, and then to this rotating pipe we press the two joint. And in this zone we have very heavy friction. The steel is melting, and we have very good welding connection. It's much more accurate than the gas welding or electrical welding. It's very accurate.
When it's rotating, does it generate heat?
Yes, because it's rotating, and because of friction between two surfaces, we have a lot of heat. It's heating metal welding, and we have very good connection.
Why we need it when we have this one?
This one, it depends. It depends on different conditions. This one is used for the small diameter pipes, as usual. But for the drill pipes, and in every, perhaps not every, but in many moments of your future job, you have to see on the objects, on the equipment, from different points of view. You must know how to use it. You must know how to do it. You must know how to repair it. So to do this kind of pipes is much more expensive. It's not so comfortable. It's much more easier to take the part, to take the tube, and to cut the thread and to connect it. For this type of pipes, we need special equipment, special initial materials. So the technology of these pipes is much more expensive. So we look in this every moment what is more preferable, what is more expensive for us, profitable also. It's not about the drill equipment. I know that it's from history. Not far from here, we live in Ukraine. So not far from here, it was the Yugoslavia country. Now it's Bosnia, Herzegovina, Horvatia. So some years ago, it was the total country Yugoslavia. They had a leader, dictator, like Germans. They had Hitler, we had Stalin, and there was the dictator. But he liked to say that he is from the workers, he's the proletariat one. He wanted to show that he is close to the people, and he decided to have the Swiss watch. But the Swiss watch, almost of them, they were in the golden or silver bodies. But he said, "Oh, I don't want the golden one because I want to show that I'm closer to people." And he, how to say?
Use?
No, ask how to, no, not ask. Asked them to make Swiss watch in the steel body. In the steel body. And this one watch was many times more
make it.
expensive
Than
than
the
the
gold
golden
one.
one. Why? Because they didn't do it at all. It was the only watch for only one person. They had to prepare materials, equipment,
Yeah,
technology,
it was
everything.
special.
Everything from the very beginning. So his steel watch was much more expensive than the golden ones. So that's why this is from the history, but I wanted to stress your attention that in every moment of your future job, you have to look on the equipment. Every mechanical engineer, if he is a producer, he has to know how, he has to be the technologist, the constructor, the designer, all the same. Some branch is bigger, some branch is smaller. Good designer, he has to know how to do it, to be a little bit technologist. The good technologist is a little bit constructor. The one who use it, he has also to be the technologist, constructor, and to want to calculate money also. Let's go on. Thanks. So your task for today. So 2 laboratory works, I am speaking, and finally I have the task for you. Here you are the 4 students. We have some, and I wanted to show you something else. In the industry and in when you use it, or in when you do it during the manufacturing of these tool joints or pipes or something like that, you need to control. Yes, there are 2 ways of control. The first way is good, but it's very long. To say whether this one is good, I have to take some tools, for example, this one or that one or some other tools, and I have to measure everything. A lot of little details, and I can say whether it's good or not. It's good way, but it's very long way. Much more easier if you produce a lot of units, you have to produce them quickly, you have to check them quickly. We use the calibers. For example, this one, they don't say us how much, but they say us, is it good or not? We just put I don't see the right for it. For example, they are different, but I don't want to waste time. Yes, I just have to put it inside and not this one. Or some of others. So what is the idea of the caliber? I put it inside the hole, or I take the outer caliber, I put it on it, and I see it, whether it's good or not. I don't know how much, but I know the answer of the main question, whether it's good or not. If it goes, it's okay. If it doesn't go, it's bad.
Should to take it off.
For you, some theoretical information. It's a little one. Task for today. You have 2 tool joints. We have 4 students. I will divide it in 2 groups.
Okay.
Yes, sir.
Any way you like. Perhaps this way or some other way,
Okay,
but
it's okay.
2 groups. 2 students for this one, 2 students for this one.
Okay.
You have to take these tools to measure not everything, but to measure some special
Details.
розмір. Як буде розмір?
Size.
Yes. Thanks. It's very easy, but I forgot.
It's what it says.
To measure some special sizes. For example, this one, not from this. So it's better to use this one. this one, the total length, the diameter here,
Okay.
2, 3, perhaps 4 of them to measure. And here we have
The
the
right
table
measurement?
on the wall. You have to measure some sizes here.
Okay.
Then according to the sizes, to find your unit there.
Okay.
It's in Ukrainian, but all the letters are the same, the Latin letters.
Okay.
And according to this information, to check which model is, yes, to determine which is the model, to identify, and then in your reports make a sketch, a drawing like this on the picture, but with all the other data that should be in the standard.
From here. The data from here.
Yes.
No, data from
At first, you measure this one.
Then we take the.
According to your measurements, you identify your joint tool, you find it, you have the picture, and you have to draw the picture in your report and to add other information which is in the standard. It's an open source information. You can use this table or you can use another in the literature, internet, journals, books, anyone. So it's from the standards. It's the open source information. It's not educational information.
Okay.
You're welcome. Do you know how to use it?
We will try.
We'll try.
You'll try. Okay. Don't forget, if you measure the inner diameter with the small one,
should open like
the result will be here. So, but if you see, when it is closed, this one goes to the 0. But if you measure the inner diameter by this one, you have to add 10 millimeters because of this material here. And if you need to measure some steps, some depth, you can use this tail or something like that, for example.
Okay.
Welcome.